Assalamu alaikum. I am Fahim Sharia Rahman. I am from School of Computing, Bachelor's in Software Engineering. Today I will present my final year project. My final year project title is Rakat Counting using machine learning. My supervisor name is Dr. Nur Azman bin Ismail. Introduction. In Islam, praying is mandatory and one of the five major pillars. Prayer is undeniable religious duty that must be performed 5 times in a day. However, Muslims often forget and miscount the number of rakat of several unintentional reasons. Sometimes this ritual activity becomes quite difficult and challenging for elderly people. Recognizing certain bodily posture during salat poses a challenge due to the limited availability of classification data, especially when dealing with several posture. A deep neural network method called one-shot learning has been effective in image recognition, which is especially designed for the CMC neural network. Therefore, this study will use CMC neural network to recognize certain body posture during salat. Problem statement. Traditionally, Rakat counting has relied on manual methods where individuals mentally keep track of their prayer units. However, in today's fast-paced world, distractions are abundant, and it is not uncommon for individuals to lose count, leading to uncertainties about whether they have performed the required number of rakat. There was a version of Rakat which was based on back propagation. However, it records video and processes the frames to identify dark frames for Rakat count after the completion of prayer. This limitation of video processing nullifies the real use of Rakat counting since it takes a really long time to process the video frames. Moreover, there is no deep learning based Rakat counter application that could successfully recognize different body posture during salat and could count rakat. Therefore, there is a need for a robust and efficient solution that utilizes learning technique to accurately and automatically count the number of rakat in real time performed by individuals during their prayer rituals. So here is my research objectives: to develop a Suzu detection algorithm based on CMC neural network, to develop a Salat Rakat count model based on Suzu detection, to develop an Android application that counts Salat Rakat and give out. So here is my research significance. The study will primarily focus on the development of SNN model that could successfully recognize the Suzu during prayer. The outcome of this research will be useful in contributing to the well-being and spiritual fulfillment of individuals practicing Salah. So here is my literature review. I used machine learning, CNN, and CMC neural network. So in machine learning, where human intelligence is unable to discern patterns in structured data, machine learning plays a particularly significant role in interpreting the data. The machine learning algorithm can be divided into the following categories based on whether the machine learns using ground truth information or not. In supervised learning, the intended outcome or ground truth is annotated on each training data sample. In unsupervised learning, without any ground truth of the data samples, the model makes decisions by discovering hidden intrinsic patterns in the input data. A branch of machine learning called deep learning teaches computers concepts that humans understand on a intuitive level. Deep neural network. So the architecture of deep neural network is composed of multiple layers of interconnected nodes known as neurons and artificial neurons. Each layer performs a specific operation and transforms the input data to produce the final output. The number of layers in the network, excluding the input layer, is commonly used to calculate its depth. Convolution layer. One of the most popular kinds of network layers in computer vision and image analysis application is the convolution layer. A convolution layer is made up of several tiny feature detectors or two-dimensional filters. These filters are learned as part of the network training process in contrast to the handcrafted features utilized in standard machine learning paradigms. The three primary hyperparameters that impact the output size are the number of filters, straight and zero padding, and they need to be established before CNN training. Pooling layers. Pooling layers dimensionally reduction is achieved via pooling or downsampling layers which lower the number of parameters in the input. Similar to the convolutional layer, the pooling layer operates by sweeping a filter across the input to create an output array. Fully connected layers. The fully connected layer receives flattened output from the convolutional or pooling layers. Convolutional layers are unlinked, meaning that the nodes in the output layer are directly related to the nodes in the layer above. This layer come before the output layer and make up the final few layers. CMC neural network in image recognition. CMC networks have found wide use in various applications of image recognition due to their ability to learn representation to compare them effectively. One of the most important advantages of CMC networks is the robustness to image transformations such as rotation, translation, and scaling. They can learn to perform the comparison task without the need for manual feature extraction. Another advantage is that they learn a reduced number of parameters because they share the same weights. One important disadvantage is that these networks have proven to be sensitive to overfitting and struggle with performance metrics which are hard to totally describe them. CMC neural network in architecture. The CMC neural network is made up of twin networks that ultimately connected by an energy function. Because the neural network weights are connected to one another, the weights of the two networks in the twin structure are identical. The conservative energy function used by the authors in cause the energy between unlike and like pairings to increase and the energy between like pairs to decrease. The convolutional and pooling layers are responsible for extracting meaningful features from the image samples of each work. The final layer in each branch is the comparison layer which generates an embedding a compact representation of the data sample. Output in the CMC neural network. The embedding is then driven through a comparison function in order to produce a prediction that decides if the two data samples are the same. Therefore, the final output of the CMC network is a similarity score, which indicates how similar or different the two input images are. This score can be used to make predictions such as whether two face images belongs to the same person or not. Methodologies. The mobile-based application for recording solid is set up first before user start the solid. The user needs to place the phone vertically in front of prayer mat so that the phone camera clearly encompasses completed body movement from initiation of prayer till the sujood. The screen of a smartphone must be facing the user. The input images of the movement of the user are automatically taken at every 20 seconds by the phone in real time during salat. CMC model development. The model consists of a sequence of convolutional layers, each of which uses single channel with filters of varying size and fixed state of 1. The number of convolutional filters is specified as a multiple of 16 to optimize performance. The network applies a ReLU activation function to the output feature maps, optionally followed by max pooling with a filter size and state of 2. Data collection. Data of sujood posture was collected from both online and real person. Approximately 84 images was collected for sujood with 100 by 100 pixel resolution. If any images are not within this, they are processed before inputting to the SNN. 40 images are collected for positive image, 30 images are collected for anchor image, and 14 images are collected for negative image. Trainings of SNN. Every sujood embedding in dataset A, we choose a group of M sujood embedding from dataset B using their conjoint distance scores as the criteria. Due to the dissimilarity between the posture in dataset A and dataset B, the M and sujood embedding are regarded as potential negative sujood pictures. Afterwards, we utilize a threshold to determine the most difficult negative photos based on the cuisine scores linked to this selection. This approach guarantees that each sujood embedding in dataset A is matched with both M positive and M negative posture picture embedding. So here is the algorithm for the SNN. Sujood verification function. The sujood verification class is initialized with a path to the pre-trained CMC neural network model. The verification threshold is to set 0.5 to indicating the confidence level. Captures the current video frame during prayer and save it to a specified image path. Calls the pre-processing function to prepare the captured image for verification. Iterates over a directory containing reference sujood images. For each reference image, pre-process it and use the CMC neural network to predict the similarity between the captured image and the reference image. The results are stored in an array. Calculate the ratio of successful detection to the total number of reference images representing the verification score. If the verification score is above the specified threshold, the sujood position is considered verified and the path of the truly verified image is stored in truly verified images. Return the true if the sujood position is verified, otherwise return false. So here is the sujood verification function coding. So here is the flowchart. Software and hardware used in the study. Okay, so result and discussion. Matrices evaluation. Precision and recall from the Keras library to evaluate the matrices. The precision metric computes the precision of the prediction with respect to the labels. The metric creates two local variables, true positive and false positive, that are used to complete the precision. This value is ultimately written as precision, an idempotent operation that simply divides true positives by the sum of true positives and false positives. If sample wise is none, wise default to 1. Recall metric computes the recall of the prediction with respect to the labels. The metric creates two local variables, true positive and false negatives, that are used to compute the recall. This value is ultimately returned as recall, an idempotent operation that simply divides true positives by the sum of true positives and false negatives. So the output of precisions and recall matrices are, we can see in the pictures. Okay, real-time verification of the train estimate. The verification function incorporates the developed CMC model to detect sujud. The verification result is defined by the proportion of positive prediction or total positive samples. The model identifies the sujud as a true if and any verification result. The following figure represents the verification function used in the study. However, when this verification function was applied in the prayer app, it was slightly changed so that it can automatically take input images at every 20 seconds and verify them sequentially. Android app development. The start pair function initializes real-time video verification, capturing frames at frequency of 33 frames per second. Stop pair halts the capturing process, release the camera, and triggers the analysis of captured frames. User can select the pair type from a drop-down spinner, dynamically populating options. This section triggers the enabling of the start pair button and updates internal variables for verification purposes. Captured frames are processed and saved at 20-second intervals, allowing for consistent verification throughout the prayers. Verification involves using pre-trained CMC neural network comparing captured frames with a set of reference images. Output of the app. Once the user presses start prayer button, the app starts to take the input images after every 20 seconds automatically and verifies the images sequentially. Based on the truly verified images, the app returns the output pair completely correct if the total true sujud count number is even and total rakat count greater than 1. This app returns the output pair completely incorrect, Saji sujud needed if the total true sujud count odd is even and total rakat count greater than 1 or higher. The app returns the output prayer completed incorrectly. Start the prayer again if the total rakat count is equal to or less than 1. Every time the user wants to the start prayer, he or she only needs to press the prayer button to start the Rakat count again. Since the app deletes all the input images every time the user starts prayer, Therefore, the app will not take any additional spaces after the prayer is complete. This is the output of the app. So this is the result of the application. So in conclusion, in general, this application uses machine learning technique to count the rakats of salat activity. In order to count the rakats, user need to use a variable that could potentially indicate the end of rakat. In this study, sujud was selected as the Rakat counting variable since it is one of the last steps of performing Muslim prayer. Then the developed CMC model verifies the true sujud during real-time prayer, performing without any additional assistance or video recording. Therefore, the developed Android app is better than in real-time Rakat count since it is based on deep neural network and it does not need to continuous frame processing. So in my project assignment, the project achieved the first objective by developing SNN-based real-time Sujit verification model. The project achieved the second objective by developing the Rakat counting system based on truly verified sujud from the first objective. The project achieved the third objective by developing an Android application based on the trained SNN and real-time counting during prayer performing. The project limitations. One of the major limitations is that CMC networks is only applicable for one-shot image recognition. This implies only a single image can be verified at a time. Other than this default limitation of the study, another major limitation is that there are no level data available for the suit detection online. So the developed model was not trained for a large set of data. One the primary limitation of the app is the simple design of user interface. The app does not contain any other features such as showing the Islamic date or prayer times. Future perspective. If the time was long enough for the project, a large amount of real data could be gathered and labeled for training the model. That would certainly increase the accuracy of the sujood detection. Moreover, if the model was trained with large enough dataset, the app would work better. In future, the other properties such as the Hijri calendar as well as prayer times could be easily generated with the developed app. Finally, due to the deep learning detection approach, the developed app is highly efficient and fast compared to other existing Rakat counting systems. Thank you. So we can